All right, I think it is recording. Okay, so again, let's pick a data set here, like, oh, the hot dog one, eek. That one's kind of frightening. So this data is from, it's either New York or New Jersey. Some restaurant there has a hot dog eating contest every summer or fall. And what this is the year of the contest and the number of hot dogs the winner ate. So in 2011, a person ate 62 hot dogs in one sitting. That's nuts. Like, what the hell is wrong with these people? Anyway, is there a strong correlation? Well, it's 0.76, which is closer to 1 than 0. So yeah, there's kind of a correlation here. It looks like over time people are getting better at eating a lot of hot dogs between 2002 and 2014. The slope here is about 1. So for each year that goes by, the winner eats 1 more hot dog than the previous year, is roughly what that slope tells us there. Now here, the y-intercept is negative 2,647. Okay, so what would that mean? The y-intercept is a point. And I'm sorry I don't have a spreadsheet to type on here, but it's the point 0, negative 2,000. So that means in the year 0, somebody ate negative 2,000 hot dogs. Okay, 2 problems with that. 1, you can't eat negative hot dogs. 2, the year 0 was when we transitioned from BC to AD, or AD to BC, whatever way that goes. BC to AD, there we go. So does it make sense for any model we create today to trace back 2,000 years? The answer is probably not. Okay, so this y-intercept is just a fudge factor. It doesn't mean anything in this case. One thing that might mean something is if we rewrote the data instead of being the year to be the years after 2002, because then we could say the y-intercept is in 2002, somebody ate 50 hot dogs. And that often happens where we rewrite the data. So I'll just give a quick example of that because I can show this on a spreadsheet. So if I take that and put it in a spreadsheet, let's just go with that untitled sheet I was screwing around with. There it is. So I'm just going to squeeze it in here. And then, because it's separated by commas and it's still highlighted, I can go to data and then split. And Excel does that too. And what I'm going to do is I'm just going to squeeze in a column. And we often do this, and you'll see this in some problems, is instead of X being the year, we do something like years after. I'm going to go at 2002. Because that means this is year 0 down here, and then this would be year 1 and year 2 and so on. And I should be able to fill that up. So then 2015 is 13 years after 2002. So I let this column here be my X instead of the actual year. And the reason we do that is a couple of reasons. It's easier to graph numbers like 0, 1, 2, 3, and so on than it is to graph 2000 and whatever. But we have spreadsheets that do it for us. So I would let this be the X and this be the Y. Because then this point right here becomes my y-intercept. And then it's a little bit more meaningful, so I can force a meaningful y-intercept by choosing my variable for X more carefully. Okay? And that's something that's done a lot. All right, so let's see, is there anything going on in the chat? So I got a couple people that say you fear the internet going out like while you're taking a test. Okay, that's an excellent question, and shit happens like that. So I try to put some safeguards in these online things for you so that you're not affected too bad. So if, like, while you're doing, let's take a look at the upcoming test this week, which I'm going to publish today, this afternoon. I'll publish the take-home part of the test. Which is not timed, and it's already published. I just need to give out the password. So I'll send a note to everybody It'll appear on the announcement and you'll get it in your inbox with what the password is. And you can start it as soon as you type the password in. You'll see the test. And it's basically one big question where I say, hey, do all these calculations and then tell me what they mean. And then you're also going to make a couple of charts. So it's like a blend of application 2 and the homework. And then this particular one here, there's a save your work button. So, and it auto saves occasionally. So if the power goes out, you'll be okay. And besides, you're doing all of your work for this on a spreadsheet. So you'll be saving, your spreadsheet will auto save or you'll be saving it regularly. So that's not a big deal. For the other test, the timed one, you've got 90 minutes to take it. So let's say like my computer just died in 90, half an hour in and I'm not done. You should be able to get back into it. Now, unfortunately, the timer will still be ticking. And so all you do is send me a message saying, I got kicked out and I couldn't get back in, and then we'll figure something out. So that's the worst case scenario. But most likely, like for me, it just took a few minutes to reboot the computer. I get back into it, I re-enter the password, and I'm back in. I set up the test so that if you're prepared, you should be able to finish it in about a half an hour, but I give you 90 minutes. So even if you have a 15-minute computer glitch, you'll still be able to finish it. So the key about the timed version is just make sure you have a nice, clean, clear 90 minutes to yourself, quiet somewhere where you can pull this off. And I would wait till toward the end of the week to do it. Some people have like test anxiety and they're just like, man, I just want to get this damn thing done. Jump in and do it right away. I decided to pull chapter 12 off of this test. So this is only covering chapters 1 and 2, which is the last 3 weeks of stuff. Okay. And the questions on that test come from the practice test. So if you've done the practice test a few times, back here, then you've seen the possible questions I'm going to put on the real test. Instead of having 21 questions, it has 8 or 10 questions. I'm still finishing it up. So if your power goes out or your computer glitches during the test, you'll probably be able to get right back in. And if there's some other catastrophic failure, we'll figure it out. Just get in touch with me, so don't sweat it. Okay, let's see. There's no other questions at the moment in the chat. Does anybody have any homework questions they wanted to ask about?
So I was having troubles on 17 and 18 on the practice exam, and I believe it's equivalent to 14 and 15 on this week's homework.
Okay, so that's Mercedes. Okay, so let's see. I'm gonna go. Which one do you want to look at first? And need a piece of paper. Can you repeat that, Mercedes? The question, so I can write it down.
So it's 17 and 18 on the practice exam, but on this week's homework, it's 14 and 15. They're similar problems.
Find a pen that works. 17, 18, and 14, 15, and they're pretty similar. Okay, so this is practice, this is homework. All right, well, I'm on the practice test, so let's jump in. And 17, 18, let's take a peek. Okay, so in this case here, okay, so what do we got? We've given some data, distance and time. So time to fly from Memphis to various cities. So there's the distance from Memphis to each city and then the time that it takes. And then I graph it here for you so you can see that the points have a nice line to them. And this says, given the distance, predict the time. So the first thing we want to do here is, now we could copy this into a spreadsheet and have the spreadsheet tell us what the equation is, or we could just look at the graph and guess. So a couple of things to note here. Let me just read the directions one more time, blow this up a touch. All right, use what you know about the relationship. Okay, so X is miles, so that's my D. All right. So when I look at this line right here, would you agree that this is an uphill trend? So that means the slope should be positive. So it can't be the first one for me and it can't be the second one. And you won't have these necessarily in the same order. So it's got to be one of these with a positive slope. And then if I line up a piece of paper, say, to this trend and I try to trace where the y-intercept might be, it looks to me that if I put a line through these, it's hitting down here under 50. So I think the best option is that the time in minutes has a positive slope and the y-intercept would be 40 minutes. So I think that's the best model based on what I can see here in the picture. So that was the point of this, to kind of look at the picture and see if you could estimate which of these equations would be the right one. It's uphill, so it's a positive slope, and the y-intercept appears to be more like 40 than 100 and something. So I would say that. Use the model you choose in the previous part to estimate the flight time from Memphis to Philadelphia. So they're just asking me to take the 874 and plug it in for the distance here. Make that calculation and then plug it in. So I'm just going to do that for fun. Copy that 874 into a calculator. And times 874, I'm going to get 153.62. So I wanted to plug that to the nearest minute. So 154. And my problem on these is I don't read the instructions very carefully. And that gets me all the time. It's kind of like when I buy something in the mail and it comes with a manual and I choose to not read it. My wife says it's a guy thing. Select the response that best tells how long it will take a Delta plane once in the air flying at full speed to travel 1 mile. Okay, so that's a question about the slope. And my whiteboard is dead, so I'm just gonna have to talk through this. Let's see. Oh no, I can type through this. Let's add a new doc and then make the font bigger, and I can type my ideas. Is that big enough? All right, so what do we got here? Okay, the best response for how long it takes a Delta plane once in the air traveling at 1 mile. All right, so they're asking about a change in distance versus a change in time. And my variables, y is the time and x is the distance. Okay, so back here, y is time over x as distance. And then they said to use 1 mile, okay? So 1 mile. So I'm trying to set this up as a fraction, kind of like 1 over the other there. And so what would be the time to go with 1 mile? So this is like a change in y over change in x, rise over run. And my slope was 0.13. As a fraction, it would be 0.13 over 1. So if I'm doing this right, hopefully, 0.13 over 1. And what is that 0.13 measured in? Back here, minutes is that one right there. So this says 0.13 minutes for every mile. There's my thing, so that's minutes. Okay, so the slope is 0.13. Since y is time, that means the slope is 0.13 minutes per 1 mile. So I would look for a sentence that has those two facts in them. And again, anytime I have to think about the slope, I gotta sketch it out. So I couldn't just do that in my head. I had to put it down on paper. I think this one right here, no, yeah. It takes about 0.13 minutes or around 8 seconds to go 1 mile. And just double check that 8 seconds thing. There's 60 seconds in a minute, so if I take 0.13 times 60, yeah, it's about 8 seconds. Okay, so that one, it turns out, is the one I want. Right there. And again, what were the cues that led me to think about slope here? They asked me to compare the time to the distance, and that's what slope does. It compares one variable to the other as they change. So that's why I thought that there. And is that the right one? Got it right. Work well under pressure some days. All right, let's try the next one. So that was 17, you said 18. 18, okay, so pretty similar. I could put this in a spreadsheet, and notice I chose X to be the year since 1990, which gives me a more meaningful y-intercept in this case. All right, plot the points on a piece of paper, which I kind of have a virtual piece of paper up there for you, and then use a straight edge to draw a line that you feel fits the data. So here's my line that I felt fit the data. Find an equation that you drew. So there are multiple answers to this problem. I tried to make it so it accepted a bunch of different ones, but if you think you had a good equation, but my system didn't like it, then you hit the message or instructor button and tell me about it, and I'll take a look. So I would pick the first point and the third point to come up with this. And so I'm going to do my best to sketch that out here. I'm going to copy this into my Word doc. I copied into OK. And then I was going to pick, what did I say? The first and the third looked kind of lined up to me. And I bet other people say, yeah, you know, I like the first and the last better. That's cool. Here's one thing I wouldn't pick. I wouldn't pick the third and the fourth because that line through there does not mimic the data. And if you tried to pick like the fourth and the fifth point, that would make a really crappy line because it's so far from the other points. So you can't just randomly pick 2 points. You got to kind of look at the picture. So I'm going to go with the first and the third. So that would be 1990 and 2000. Okay, so back here. So then to find my slope, I need to find the rise. And again, I'm going to use this one here. Let's highlight it. And this one here. Highlight. So my rise on this one would be 5 minus 3.25. And a calculator would be helpful. What is that? That would be, oops, I can't type. That would be 1.75. And the run, we have to keep things in the same order. So since I started with 5, I have to start with 10. So that'd be 10 minus 0. So I get a run of 10. So my slope would be dividing those two. So slope is 1.75 over 10. Now, every once in a while, I screw up the order of stuff. So notice this subtraction is positive, this subtraction is positive. Positive over a positive is positive. Slope being positive means that these numbers go uphill from left to right. And if I look back at the picture, yep, they go uphill. So I didn't screw up the order of the subtraction, which I do sometimes. And then I should clean that up. So if I divide that by 10, then, oops, I get what? 0.175. And then what does that number mean? Well, the rise was minimum change in minimum wage, so that's dollars. And the 10 was years. So my slope must be dollars per year. So $0.175. So like if I were to interpret this for my mom, then I would say something like the minimum wage seems to be rising, right? It's going uphill. It's not just changing, it's rising. Rising by about, I'm going to call it cents. So I'm going to say 18 cents per year. But you could have said $0.0175 too. But I think my mom would appreciate the 18 cents better than the 0.175 per year on average. And I'm even going to be a little bit more clear. I have no idea what was happening before 1990, and I have no idea at the moment what happened after 2010. So I'm also going to be even more clear and say it was between 1990 and 2010. So that's about as clear as I can get for interpreting the slope. And then again, interpret means it kind of like explain. What the heck does it mean? It doesn't mean how did you get it? I don't really care. I want to know what it means. My mom doesn't care about all this work I did here. She just wants to know, hey, what does it mean to me? Which is kind of the point of this class. All right, so let's see. Have I gotten the main parts there? I got the slope. Now the y-intercept, that is given here because I give you 0, that. So I would say my line, let's see, W is for wage, so W for Y equals 0.175 and T for X plus 3.25. And so I think when I program this question, it accepts a slope anywhere between like 1.6-ish and 0.2-ish, like up to 20 cents per year. And the slope should be around, the y-intercept should be around 3. But in this case, those 2 points look pretty nice. Definitely you wouldn't pick the last 2 because that'll give you a way steeper slope than we see here. So you do have to selectively pick. Interpret what the slope means. That was what I was doing back here to the best of my ability to articulate that today. All right. Oh shit, it just asked for the slope up there. I can't read directions. You guys need to tell me when I'm not reading the directions right. Cut, paste, slope, 0.175. And usually, you know, I forget to read these cues. Enter an integer or a decimal, right? It doesn't say enter an equation. This one down here says enter an algebraic equation. Equation means it's got to have an equal sign. And if you accidentally type the wrong letter, it should warn you. Syntax error, check your variables. And I always, not always, but I occasionally screw that up. Okay, then it says make a prediction out to 2020 and then figure out in what year the minimum wage might have been $15. Okay, so 2020, the key there is, again, remember that T is years after 1990. So 2020 would be 30 years later, okay? So calculator, I would take my 0.175 times 30 plus 3.25 was my model. And feel free to copy my model since you're watching. But it's kind of fun to make your own. So my model predicts that it would be 850 in 2020 this year. And the 0 doesn't matter, you could type it or not. And then when will it be $15? That's a bit harder. So in that case, I need to solve an equation. So my equation was W equals 0.175 times T plus 3.25. And they say, okay, let W equal 15, figure out what T is. So putting that together, my equation is 15 equals 0.175 times T plus 3.25. And just a reminder about, this is one of the few times we'll ever solve an equation in this class. We do hardly any algebra in general, mostly just calculations, arithmetic stuff. Solving an equation, if I knew what T is, I multiply first, then add. To solve, you have to reverse that. So that means the first thing I need to do is get rid of the 3.25. So I want to subtract 3.25 from each side. Subtract, thank you, Google. What would we do without spell check? Right. You've seen me 30 years ago without spell check. So 15 minus 3.25 is going to be 11.75, I think, equals 0.175 T. And I guess I should double check that. If I add 3.25 back on, that's going to give me 12 plus 3 is 15. Yeah, that looks right. Then the next thing I should do is divide by 0.175. So whatever 11.75 divided by 0.75 is my answer. So I just need to whip that into a calculator. Calculator says it should be 15.666, so I would round that up to 16 years after 1990, so plus 1990 because I suck with dates. It looks like the year 2006.
I think you were supposed to, did you miss a 1 in that 175?
Did I miss something? Oh shit, good job, Michael, thank you. 175. Holy shit, 67 years later. You know, that makes more sense based on that 2020 answer, because it should be farther ahead than 2020. Thank you. Yeah, it's always good to kind of double check if things are reasonable, and or have somebody looking over your shoulder say, hey, look, you forgot a digit. 67 years after 1990 gives me the year 2057, right in the beginning of 2057. In what year? Yeah, so 2057, make sure we read the instructions. So that was that one right there. You could enter this into a spreadsheet and tell the spreadsheet to find the line of best fit. You'll get a slightly different equation than I got right here. So just for fun, how that works again, paste your, ooh, shit. And paste your stuff in, copy carefully. There we go. And then select your X's and Y's and say, make me a chart. And Excel works pretty similar, except you would use the insert recommended chart. Switch to scatter plot if it didn't already, and then ask for a trend line. And then ask for the equation. Pretty close. They said, yeah, the same slope works, but use 3.2 would be a better y-intercept, is what the computer says. So a little different than what I came up with. But either answer should be acceptable. All right, we are a little over time, but that's okay. It's a beautiful Tuesday to do math. Any other questions before we part? And thank you, Mindy, for correcting me, and April and Justine. You guys rock. Wow, nice job. Not at the moment. Okay, so reminder, when you do get stuck on these questions, remember you got that message instructor and button. That is different than the Canvas inbox, but it shows me the problem you were working on and anything you typed in, so I can help you troubleshoot it. So that's a useful button to push whenever you're stuck. And on most of these problems, if you spend more than like 15 minutes and you're not figuring it out, then you should ask for help. But I will often respond like, did you check out this example in the book? So if I already have a video or I know it's in the book, I'll point you to that. Otherwise, I'll type up a response for you. All right, well then take care, do good math. Look later today for my note about the exam. I'll post the password for the take home today, and then the timed one tomorrow with details about my expectations. Bye-bye.